In the previous episode, Claire and Mary plotted several points on their graph of the sine function, which relates the angle of rotation, measured in radians, and the height above the midline, measured in radii, of an object traveling along a circular path. In the previous episode, they plotted points where the object's angle of rotation was 1/4 pi radians, 2/4 pi radians, 3/4 pi radians, etc. They have since added in 3 more points. In the last episode, they determined the height above the midline at these angles by simply copying the physical height above the midline using a circle whose radius was literally the same length as 1 unit on the y-axis of their graph. In this episode, they will reflect on how to use a calculator to obtain these heights. They begin by trying to find the height of the object when its angle of rotation is 1/8 pi radians. They grapple with how to put this into the calculator, and whether or not the height of the object when its angle of rotation is 1/8 pi radians is just its height when its angle of rotation is 1/4 pi radians divided by 2.
So I'm curious if you could actually even just use the calculator to help you find those values.
Okay. So it'd just be that divided by 2?
Yeah. I'm just gonna answer divided by 2. 0.39 approximately.
Yeah.
The students seem to think that you can find the height of an object when its angle of rotation is pi/8 by entering pi/4 into the calculator and dividing by 2. Do you agree or disagree? Why or why not?
Use your calculator and the sine function and see if that also matches.
Oh, okay. Oh, wait, you can plug the sine function into the calculator?
Pi over 8. Yeah, we're good.
That's pi over 8. Did you do sine?
Oh, my bad, my bad.
So let's make sure that, remember, I think we might be in degree measure, but let's see what happens if we put it in degree.
Yeah.
It's like pretty close.
0.382.
The students have discovered that you cannot take the height of an object when its angle of rotation is pi/8 by calculating pi/4 and dividing it by 2. This is because you need the sine function to calculate the height. You also cannot find the height by taking the sine of pi/4 and dividing by 2. This is because the sine of pi/8 is not equal to the sine of pi/4 divided by 2. Before watching the rest of the video, take a minute to think about why the two expressions are not equal.
Do you remember in the first lesson we talked about how they change at different sort of rates? They increase slowly
like
or decrease slowly, like the steepness.
Oh, yeah.
Yeah. So for that reason, we can't actually take those heights and divide them by 2 because we won't.
Because they're different steepness levels.
Because they're different steepness levels. So they don't increase in like a linear way. They don't increase proportionally like that.
Yeah.
Yeah.
So we'll just do 8.
Nice. Okay.
The students found the height of an object measured in radii when the angle of rotation is pi/8 radians using a calculator. They did this by typing in sine of pi/8. The sine function's input is the object's angle of rotation, and the output is its height above the midline measured in radii. Thus, this calculator is telling us that when the object's angle of rotation is pi/8 radians, or in other words, when the object has made 1/16 of a full rotation, the height of the object above the midline will be about 0.38 radii. It is important to note that in order to get an accurate answer, you need to tell the calculator if you are measuring your angle of rotation in radians or degrees. If you were to put into the calculator sine of pi/8 and the calculator was in degree mode, it would think you were asking for the height of the object when the angle of rotation is pi/8 degrees, which is less than a single degree. The students also said that you could not find the height of the object at pi/8 radians by finding the height of the object at pi/4 radians and dividing by 2. This is because the object gains more height in the first pi-eighths rotation than it does in its second pi-eighths rotation. The students will now use the calculator to find the height of the object above the midline, measured in radii, at several other stops by inputting the angle of rotation, measured in radians, at these stops.
And you want us to do that for the other 3 that we did?
Yeah, do that for the other 3 that you did.
Okay. Wait, so can you just put the sine function into the calculator?
Mm-hmm.
Oh.
So the sine function in the calculator, someone has actually done all of this work for us, where they've used all the pipe cleaner measures and they've figured out all of those ratios. And so that's sort of the magic behind the calculator.
Yeah.
So that's why we can use the sine function on the calculator.
Yeah. That's 0.92.
So do those inputs and outputs make sense?
Yeah.
Yeah. Why?
So 0.38 is a pretty small number. I'm going to make this a little bit bigger. There you go.
Whoa.
And this is a pretty small line.
Mm-hmm.
So that makes sense. And then for 5/8 we got 0.92, which is almost 1 radius. So, and it's right here, and it's almost 1 radius. And then for sine of 7/4 pi, this one is underneath the midline, and we got a negative number. See, it's right here, and it's below the midline, and we got negative 0.71.
Yeah.
To me, that's why it makes sense.
That makes
Yeah,
sense.
that makes sense to me. That's literally how I would have said it. So.
Yeah.
In this lesson, Mary and Claire figured out how to graph the sine function. The sine function can be thought of as relating an object's angle of rotation with its height above the midline as it travels along a circular path. The sine's input is the object's angle of rotation, usually measured in radians, and its output is the height above the midline, measured in radii. The students created graphs by considering the angle of rotation and height of an object at several stops along its circular path. For each of the stops, they figured out the angle of rotation and then found the height above the midline by taking virtual pipe cleaners and copying over the height. This copying worked because they made one unit on the y-axis the same length as the radius of the circle they were using to find the heights. They also found out a calculator can provide these heights. If the calculator is in radian mode, you can type in the sine of an angle measured in radians, and it will give you the height above the midline measured in radii. In the next lesson, the students will explore how to transform the graph of the sine function to model a particular situation.